The Atlas V rocket is one of the largest currently available for interplanetary flight. It has already propelled InSight and Curiosity to Mars, so what is planned next at Cape Canaveral? Stick around to find out. Hello everyone, and welcome back to Elder Fox Documentaries. Today's video will feature everything you need to know about the upcoming launch to Mars. We hope you enjoy it. Let's start with a bit of an existential question. Why Mars? Well, for one thing, human curiosity. We have planted feet on the moon, so Mars seems like the next logical destination for a manned mission. But lofty goals require plenty of forethought and research. The pull of the unknown draws us to Mars. Sure, Columbus headed west and Marco Polo headed east, explorers looking to map uncharted lands. But this was on Earth, our home, not another planet. Sending people to Mars seems like the next giant leap for mankind, but it really is a journey into the unknown. Before we send a crew of brave men and women on an almost 2-year journey spanning 100 million kilometers, we had better make sure that they can thrive once they get there. Sending robotic probes to scout ahead can answer key astronomical questions about the potential for life on Mars, not only giving us information on whether Mars was once capable of sustaining life, but also whether there is a potential to build a habitat and populate the planet. The Perseverance rover represents the latest in a long line of remote robotic exploration vehicles sent to the Red Planet over the last 44 years. It seeks to answer further questions raised by its predecessor, Curiosity, which made its landing on Mars in 2012 and was the most ambitious mission flown by NASA at that time. This little engine that could has now been on Mars for almost 8 Earth years, 2,835 Mars days to be exact. It has fulfilled its primary mission of finding evidence of organic molecules and geological change on Mars. It continues to explore and search for water in the form of ice. So where does the Perseverance fit into the mission? Perseverance, although based on Curiosity's design, will carry different instruments to better probe for ancient life. The main goal will be to both confirm that past conditions were habitable and also look for signs of actual microbial life. Sorry to disappoint, but the rover is not likely to encounter little green men. But first, it has to make touchdown. It's the reason why Curiosity's blueprint was used as a basis and improved upon. NASA hopes to replicate its success. This video is made from a series of images Curiosity took on its way through the Martian atmosphere. The frame rate is low, but we can see Mars as Curiosity did when it descended. Looking back at Curiosity's famous 7 minutes of terror landing sequence gives us a valuable insight into the way Perseverance will make its approach to the red dust of Mars. This process may look crazy, but it's the culmination of the combined engineering knowledge of some of the best minds on this planet. There is pretty much a zero margin of error. It will take all of 7 minutes to reach the surface from the top of the atmosphere. The kicker is that it takes 14 minutes for information to be beamed back to Earth. There will be no opportunity for human intervention. The descent must be controlled autonomously by the onboard computer. The approaching craft will initially hit speeds of 30,000 miles per hour and must decelerate to 0 miles per hour in perfect sequence and timing in order to not sustain damage. Nothing can go wrong. Once entering the atmosphere, the heat shield encounters such severe aerodynamic resistance that it glows like the surface of the sun, hitting a temperature of 1,600 to 2,100 degrees Celsius. Not only does the craft have to be slowed down tremendously quickly, but it also has to be guided to the landing site. By the time the parachute deploys, the craft is still traveling 1,000 miles per hour. It's the largest and strongest supersonic parachute ever built. It opens so fast that it pulls 9 Gs. At this point, the heat shield must detach. Like a lens cap on a camera, it will be blocking the radar's view of the ground topography and distance. The radar has to take altitude and velocity readings at an exact, precise time, or else the landing will fail. The parachute will only slow it down to 200 miles per hour, nowhere near slow enough to land. There is no choice but to detach and cover the remaining distance with retro booster assist. The next issue is that the rockets can't be used all the way to the ground, as they will kick up dust, covering the rover and damaging mechanisms and instruments. This problem is solved by using the sky crane maneuver. 20 meters above the surface, the rover is lowered below the lander on a tether that gently deposits its wheels onto the surface. The bridle is then cut away and the lander flies away to a safe distance to avoid landing near or on top of the rover. returned them to Earth for intensive laboratory analysis. Future human exploration of Mars depends on a technology for extracting oxygen from the Martian atmosphere, which is 96% carbon dioxide. The caches will give vital clues as to how the process can be perfected. The new technology helps mission planners discover ways of using Mars' natural resources to support human explorers and improve designs for life support, transportation, and other important systems for living and working on Mars. The Perseverance rover will answer questions that Curiosity could not, but we must not forget the great work Curiosity has done. Click here to see new footage of Mars rendered for the first time in stunning 4K quality. If you enjoyed this video, please give it a like and let us know in the comments what you think the rover will find in the Jezero crater. Tell us, we love to hear from you. Thanks for watching Elder Fox.